All right, 1.8, we're going to look at combination of functions, composition of functions. We're going to add, subtract, multiply, and divide. Find composition functions of one function with another in its domain, and model them. This is a review from Algebra 1, Algebra 2. And basically, we have here, there are two functions with overlapping domains. If we want to find the sum, we add them, we subtract them, we multiply them, we divide them. So let's look. This is just a quick review of composition functions. So, might be written a little bit different, but f plus g means add the two functions together. Well, f of x is x squared plus g of x, which is 4x minus 3. Then what's the domain? Well, the domain for f of x is all reals. The domain for g of x is all reals. So the domain for both of them is going to be all reals when we add them together. Adding's no big deal, but when you subtract, you need to be a little bit careful. F of x is x squared. We're subtracting the g of x function. So that's going to be negative 4x plus 3, domain all reals. Questions there? Okay, C and D kind of got lost down here. What's f dot g mean? Multiply. So that means I'm going to take the g function, multiply it by the f function. X squared times 4x. X cubed, x squared times 3. Just, yeah, 3x squared, thank you. Questions on C. D then is take the f function, which is x squared, divide it by the g function, which is 4x minus 3. That's easy enough. It doesn't divide, so we just leave it. What's our domain here? Can it be all reals? Yeah, we can't have 0 on the bottom. So where does 4x minus 3 equal 0? Well, that's at x is 3/4. So our domain is all reals except x cannot be 3/4. Questions there? All right, then it says take and find f plus g of negative 2. How do we want to do this? Put negative 2 in for x's. So we want to find f of negative 2. We want to add to what we get when we plug in g of negative 2. So this one is what? Negative 2 squared, which is 4 plus 3, which is 7. This one's negative 2 minus 5, which is negative 7. And what is 7 plus negative 7?
Negative.
Negative 14.
Negative 7 plus negative 7.
I might have. But it's positive 7 plus negative 7. It's on video. We could go back and listen if we need to. Okay, so for this one, we find f of 4 divided by g of 4. Well, 4 squared is 16. Plus 3 is 19. 4 take away 5, which is negative 1. And 19 divided by negative 1 is negative 19. Questions there?
Yeah, what is the 1/8?
Where'd I get what?
For D, it says 1/.
This is f over g.
Just can't see this.
It does look like an 8. Other questions? Okay. F times g of f of t. F of 5t. So that means f of 5t times g of 5t. So x squared plus 3, so that's 5t squared plus 3. Multiply that by 5t minus 5. So 5t squared is 25t squared plus 3 times 5t minus 5. Now you get to distribute. 25 times 5, 125t cubed minus 125t squared plus 15t minus 15. Questions there? Okay, use the graph of f and g to graph h of x, which equals f of x plus g. Well, you don't have the graph of f of x and g of x, so let's get it on here. First one is at negative 5, negative 2. And then negative 1, 3. And 3, 0. That's going to be f. Do G in green. So 3, 4. Negative 1, 4. Negative 5, negative. Negative 5, 5. So given a graph, how do I add them? Well, what did you do what happened when you plugged in the x values? What did you add? You added the y values. So you just add the y values. So right here at negative 5, this is a negative 2 and this is 5. So what do I get when I add 5 plus negative 2? 3. This is 3. This is 4. What do I get when I add 3 plus 4? 7. This is 0. This is 1, 2, 3, 4. What's 0 plus 4? 4. So our h of x looks like that. Questions there? This is kind of hard to see, but a composition is f of g. It kind of looks like the word fog, which means f, they could write it like this, which simply means you take the g function and you plug it into the f function where you see the variables. Remember doing this in Algebra 2?
Yeah.
So let's look at some examples. F of x is x squared plus 4, and g of x is the square root of x. So they want us to find f of g of x.
So we put in g of x for x.
So that means this is going to go right in here. So that's going to be the square root of x squared plus 4. Which equals x plus 4. And then I didn't talk about this, but the domain of f of g of x is a set of all x in the domain of g, such that g of x is in the domain of f. So our domain is going to be what our g of x domain is. And in this case, g of x is square root of x. So x has to be greater than or equal to 0 because I can't square root a negative number. How do I do g of f of x? This goes in right there. Does this simplify? Please don't tell me x plus 2. There's that plus sign there. That would be like if I took the square root of 9 plus the square root plus 4. Order of operations says I do 9 plus 4 first, which is 13. If I square rooted 9, I got 3. I square rooted 4, I got 2. They don't equal. Okay? Only time I can square root them is if it was times. Alright? What? What's the square root of 36? And 3 times 2 is 6. Alright? So if there's a plus sign there, please don't square root it. What's our domain? Well, our domain is, what's the domain of f of x? What's the domain of f of x here? All reals, so this is going to be all reals. What about f of x? That means I take f and I plug in x squared plus 4 for the variables, which is going to be x squared plus 4 squared plus 4 what's x squared plus 4 quantity squared? X to the 4th plus 8x squared, 16 plus 4. Remember, x squared plus 4 squared means x squared plus 4 times x squared plus 4. And there's that shortcut that says I square the first. Middle term are these two multiplied together and doubled. That's 8. Then the plus 16 is the last term squared. And then there's that plus 4. That little shortcut's going to come in handy in this class and in calculus. Domain is all real because the domain of f of x is all real. And then for D, g of x, that means I take the square root of x and plug it into the square root of x. So that's the square root of x square rooted.
Wouldn't they just cancel out then?
No, they're not opposites.
Oh, okay.
So let's talk about this. Can't I take that outside radical? That means I take it and raise it to a half power, correct? The square root is the same as raise it to a half power. I do the same thing for the inside one. Square root is the same as raise it to the half power. And now power to a power, what do I do with the exponents? Multiply them. So what's 1/2 times 1/2? 1/4, which means that's the 4th root of the square root of x. And our domain, well, what's the domain of g of x? X has to be greater than or equal to 0. questions on that? Example 5 says use the graphs of f and g to evaluate each function. So let's go over here. And the f function is going to be I don't know. How am I going to do this? Put it right here. So the f function is an absolute value type function. It's not the parent function, where it's at 4, 0, or 0, 4. This is 1, 2. This is 2, 0. Negative 2, 0. Negative 1, 2. What we want to do is we want to find f plus g of 2. That means I'm going to find f of 2 and add it to g of 2. So what is f of 2? This is my f function. Here's x is 2. What's y? 0. What's g of 2? It's negative 1 right there, which gives us negative 1. Then f of g of 1, that means I have to find g of 1 first. What is g of 1? Negative 2. Then I go over to this function and I find what f of negative 2 is. 0. Questions on A or B? How'd I get what? I had to find g of 1 first. So I went over to this function. Here's 1, and that's -2. So then I found f of -2 by going to the f function, going over to -2, and the y is 0. F of 3. What's f of 3? Right here's 3. Each of these are going, x's are going down by 1, y's are going down by 2. So that would be -2. So then what's g of -2? -5? Questions there? We're going to take this a little step further here. Find two functions, f and g, such that f of g of x equals h of x. So I'm giving you the composition function. You've got to find the two functions. Now remember, g of x is the function you put into the other function. So what do you see here? You see 4x minus 7 squared. What do you think g of x is going to be? 4x minus 7, which means f of x will be x squared. Does that make sense? Can you take this 4x, put it into AF, do you get this? You do. What about this one? What do you think f of x is? 1 over x cubed. And then what's g of x going to be? X minus 9. Questions there? All right, example 7, last example here. We have a function, n of t. The number n of bacteria in a refrigerated food is given by this, where T is the temperature of the food in degrees Celsius. When the food is removed from the refrigerator, the temperature of the food is given by this. T is between 1 and 20. Small t is between 0 and 6, where t is the time in hours. Find n of t of t. So what do you have to do here? Plug in 3t plus 2 into, so that's going to be 10, 3t plus 2 squared, minus 20, 3t plus 2, plus 600. So what's 3t plus 2 squared? Let's use our shortcut. Square the first term, what's that? 9t squared. Middle term, are these two multiplied together? So 3t times 2. 6t, and double it. 12t. Last term squared. And that's minus, distribute the 20. 60t minus 40. Distribute the 10 through. T squared should be 120 minus 60 is 60t. (40 minus 40 plus 600). This is the number bacteria as a function of time and it's going to be in hours. One person from each group. Calculators for people in the groups that we know.
Sure. Yep.
Alright, B. In order to solve this, we could use the quadratic formula, but we are now pre-calc students, and I believe that you can use the quadratic formula. So we are going to use our graphic calculators to find the time when the bacteria reaches 1,500. So what are we going to do? We're going to go to y equals first of all, if you have a stat plot on, turn them off. And we're going to plug in our function, which is going to be 90t squared. In this case, we're going to have to use x squared. Plus 60x plus 600 and then we're going to have to put in y2 is 1500. Now before we hit graph, we're going to have to change the windows. Now we know that time is between what? Up here at the original problem, it says between 0 and 6. So we're going to make our x minimum 0. Let's make our x maximum 7, just so we can see everything we need to. A 1 scale is good, because we only have 7 there. Y minimum is going to be what? Well, when you put in 0 for t, what do you get? 600. Just look at the function. Look at this equation right here.
That's two more than.
So we want to have our y minimum to be 600. We're looking for 1,500. Mine already has 2,000 there. You think that'll work? That's more. Now, what do you want our y scale to be? Well, that's about 1,400 points there. We do 200. We'd have 7 there too. So make our y scale 200. Everybody with me? Anyone not have this stuff filled in? Hit y equals, or graph, I'm sorry. Okay, there's our t squared. There's. All right, so you see where they cross. So how do I find that point? Second, calculate, intersect 5. And then get that little flashing thing to where you think they cross. Close enough. Enter, enter, enter. And you get a time of 2.85 seconds.
Why is it not hours?
You are right. It is hours.